Hello, and welcome to the 8th video in our series of demonstration videos for the VPAT tool. In this demonstration video, we're going to look at the LPAR defs function. The LPAR defs function allows us to go into our EDF data or our RMF input data that we used in the extract process, and it allows us to look at the configuration that was in effect during any individual interval on the system. This can help us with problem diagnosis, or it can help us with understanding the effects of certain weighting changes and other similar configuration changes. So let's take a look at how this works. We're going to go into extract here, and we're going to say that we're going to extract from an EDF format. We'll take in all of our systems, and we're going to click OK. We're going to go into our demo1 file, and there's that EDF file we've been using all along, same one we use in the extract process. This time we click on it, and now we get a roster of when do we want to look at our LPAR def, what was in effect at which time. So we can scroll down through here and look at what interval is of most interest to us. If we continue to scroll down, here's an interval where we're at 100%. So let's select that interval. When we select this interval, VPAT is going to go in and produce us the configuration information that was in effect at the time of our interval. So we can see the polarization of our processors, how many vertical highs, mediums, and lows we've had. We can see all the weights and how they're defined. And importantly here, we can look at how possible weighting changes can influence the changes in our processor polarization. So in our earlier capacity planning example, we talked about maybe taking capacity away from Dev 5, so possibly reducing that down to a weight of 10. And we talked about adding in that same weight, that weight of 78, and making this 880. And if we do so, we can see that we've now gone to 8 vertical high engines instead of only 7, and we've reduced the number of vertical mediums and lows that we have. Now, this can improve performance even further on our Prod 3 LPAR by giving us greater access to the 8th engine here and having it almost dedicated through hyper dispatch to our LPAR. So this is the functionality that we can get out of this screen, letting us make configuration changes and seeing what the anticipated changes will be in terms of our processor architecture. We can see the same decision making for our zips and our ICFs and our IFLs based on the input data, and we can see that the configuration information will change here as needed. If we want to click on Save LPAR Text, it will basically take these 4 screens and put them into a text file so that we can save that and use that for a later purpose. Now, if we wanted to look at anticipating how this would work in combination with other machines and merging other LPARs together, what we can do is we can go on here, we can modify the number of engines that we have. Now, this is purely based on LPAR weighting and number of engines. So this has nothing to do with our individual MIPS or MSU specifications. This is purely a mathematical exercise on percentage usage. But if we wanted to combine other systems here, what we would do is we could save this set of definitions, which would save these LPARs. We could then go through the extract process again and perhaps pick up a different system here, different set of LPARs here. We could then say combine. And at the combine point, it would take what was on the screen and look to point us to a saved set of files, and it would produce a consolidated consolidation view of all the LPARs combined together. So this is just a basic overview of how this process would work. You then have the option of going in and manipulating all your LPAR weights, making sure your totals add up here. If you don't add up to 1,000, VPAT will still process the data properly, so it properly does the math. So if we were to make this 20 here, for example, we can see that we still are going to have our capacity numbers properly reflected at 100%, even though our weights don't total. So this can be useful also to help understand distributions and properly setting weights. That's the end of this demonstration. Again, LPAR defs is a fairly simple concept. Please stay tuned for our next video where we're going to look at the basics of the simulation functions. Thank you very much.